if you, oh, I better start the, restart the recording. Hang on. Almost forgot. I'll get there. Okay, starting again, now being recorded. So we're live. Let me start with a couple of announcements, I guess basically, yeah, 2 announcements. So I think these went out on Tuesday. We have set up for the homework number 3, which we're not there yet. So you don't need to worry about this just yet. But you've received these email announcements, and for now, I think you can just leave it stay where it is. You don't necessarily have to accept the lab assignment because we're running into issues. Once you accept the lab assignment, where access to resources in Azure is, let's say, proving problematic. Let me see. I'll show you what I got the other day, for instance, from this is a communication on GitLab, which you can see, which is from Kang, who is a TA for 344, Alyssa Pittman's class. We're tracking along the same lines. Earlier today, Alyssa and I chatted about where we're at with this. We are finding that it's not easy to create SQL databases under Azure at the moment. You get a message that the resources aren't available wherever you try in the world, wherever in the world you were trying. It's related to volume, it's related to capacity, whatever they're doing with the whole world being remote. And, you know, apps like Zoom, for instance, where do you think they're getting capacity these days? Maybe they use AWS, maybe they use Azure, I don't know. Microsoft Teams, which they're starting to give away free, is similar meeting kind of and collaboration facilities. I talked to a lot of people that are using that, and they're all grabbing resources at things like Azure. So we are considered, unfortunately, a lower priority. I first ran into this over the last week when I was trying to, you know, I showed you last week, I showed you this web score database, and I just navigated around some of the database for you, and maybe ran a query or 2. And I'm hoping to use that throughout the class as a more realistic database for you to look at, or something at the next level of complexity compared to, say, flights, which a lot of your exercises are going to be. You're going to be using flights in the next exercise, and now your exercise involving flights is the one that we were going to put flights up. So that's what this is about. However, as you see, we're having issues there. As I said, I started to see them last week when I was trying to put up an Azure SQL instance that I could load the web score data. I think the data is about 6 or 7 gig. So I was just going to put it up one place and then give you guys access to it if you wanted to see what, play along at home, what, the home game while I'm playing with it during class. So I ran into it, and then if you remember going back to the welcome letter that I wrote you all that you got Sunday before the first day of class, I have a section there that talks about other SQL Server resources for the sake of doing local installs. And unfortunately, the TAs who have all taken this class and gone through Azure, they're not particularly trained up in doing local installs on SQL Server. So we're working behind the scenes to get out in front of you. The local installs are actually pretty easy. It's a setup routine that you download. There are different versions for Windows, for Mac OS, and for Linux. So they have a 180-day free trial. So we can all enjoy using SQL Server free for 180 days. I was a little worried about the free trial because it means at some point you're probably going to get an email from a marketing person in Microsoft. Just tell them, thanks, but no thanks. But it looks like that's going to be our preferred way of doing homework 3. We're not quite ready there. Chris Nye, who has been working both sides of this, it's one of the TAs. She and I have been working. She's doing all the work. I'm just watching what she's doing and saying, well, try this next, try this next. She's got everything working, and we're trying to package it up for you in a way that makes it really a snap. We have to update the documentation and things like that. So we're not really ready for you to do this. If we do want you to try Azure, I might do it as kind of a controlled rollout, as that bullet point says, where maybe we try it for 10 or 15 people. And if you don't mind being frustrated, accept your lab assignment, try to spin up an Azure SQL. I don't think you're going to have much success. I tried it again today, and I didn't have any success. Alyssa Pittman, she tried it. The fellow Kong has been trying it. So we don't think this is going to work. But local install is not a bad option. It's how I run a SQL for the most part, although we also run Azure SQL in my company. I think we'll get through this, and once we do the local install, you'll be using SQL Server for the next 5-6 weeks in the class. So I think you'll be in good shape. We'll stretch out that assignment a little bit. And again, we're preparing on our end, and I don't know the full story. I'll have more of a story for you on Friday. We'll see where we're starting to land. When I talked to Professor Pittman today, she mentioned that she was thinking about ways for you guys to, have some contact with each other, which you don't get because nobody's on campus, nobody sees each other at class or anything like that. And she suggested that to her class that you do something like virtual study groups using Zoom. I don't know if we can help do that with you, if you want us to help and aid and abet that a little bit, but I just thought I'd mention that. It seemed like a good thought. Okay, so this is not homework yet. This is not homework yet. You're on homework 2. Stay on homework 2, finish that up. When we do get to homework 3, we will take the same flights database that you know and love today, and we will have you move that into Microsoft SQL Server, which is a very different experience in a way. But I think you'll be probably looking at installing a copy of SQL Server to run locally on your PC or Mac or whatever it is you own. Okay, so that's where we're at. Hang on, I'll give you more detail about that on Friday. Right now, just focus on hardware 2. If we do wind up doing the SQL Server stuff, it's probably going to be a long time, although, get ahead of things like the install. You'll want to, by next Thursday, have tried to do a SQL Server install and bring any problems that you might encounter to the lab section so that TAs can help you work through them. But I don't think you'll find it too difficult. It's pretty easy. But that's, my view of what's easy and your view might be kind of at odds. Okay. I'm missing a slide here, I thought. Oh, no, here we go. I'm looking at the wrong slide. So just by way of, after every class, I do the one-on-ones afterwards. They're great. I really encourage you, if you have questions, to come there. I also look at the traffic out on the discussion board and see those kinds of questions. And I've taught this class once before. It also sometimes jogs my memory about what kind of questions came up the last time I taught it. So what I'm going to do is relatively quickly, review some of the things that we've talked about so far in the newer section. But one thing I wanted to make super clear to you guys when we talk about join and what I'm trying to teach join. I'm not trying to teach all of join and all of data. By the way, my voice level, my audio level is okay? Okay. So understand that you can join, as in set theory, you can join any two tables if long as they have a common column to join on. So you can join. You can even join 2 tables if they don't have a common column, sorry, but that's not a equal join. That's more like a cross product kind of thing. But in general, we're looking at joining two tables, and we'll see how this emerged in upcoming classes in the way in relational algebra and the way relational databases develop, why we get so many of them. What I was trying to do in the last class and continuing today is I'm focusing on the most common join operation you will find in relational databases. And that's an inner join. More specifically, it's an inner join that it's an equal, so it's called an equijoin. And we've seen that there are two ways to specify that, specifically with the join keyword, join to. And but join is implied whenever from references multiple tables. So from with a where clause that has an equals a predicate, something in one table equal to the other predicate, it becomes an equijoin. And in particular, the kind of join you're going to see frequently in your homework, which is set up this way, in real databases, in the WebScorer database that we're going to use for demonstration purposes. You're going to see joins involving foreign keys. And I'm using the term constraint here because I haven't really talked enough about constraint to want you to understand everything that's going on. The one constraint that's important for you to understand, aspect of the foreign key constraint, is that a foreign key constraint says that you can't stuff a value into a foreign key field, which references a primary key in another table. That's the relationship that's being modeled. You can't do that unless that primary key value actually exists. So those tables that have foreign key constraints with a foreign key pointing to a primary key, those tables are kept in lockstep. They're kept in order. They're kept with what we call referential integrity. As we look at the way constraints work in SQL Server, we'll see how that constraint, that referential integrity is actually implemented and how it works. What happens when you try to delete the primary key, for instance, which is a constraint on the foreign key. So we're going to get to that. I'm not going to explain that now, but there's more coming in that area. And these are important. This is how relationships are modeled, and this is usually how tables are joined. Okay, so just that clarification. But the thing that it's new that I'm adding today is you can join any two tables on any, as long as they have a common column. So that will happen. The most frequent kind of join, though, is this kind of a join, a foreign key constraint joined to the table that it references where there's a primary key. We'll get into the details of this as we go through the class. There's a lot more to learn in there. Just keep that in mind as to what that content is about. Okay, now we've been adding to your SQL, your knowledge of SQL, and last time we talked about the summary functions that are available in SQL. We saw 5 summary functions: count, sum, average, max, min. Just going over this quickly again. These are called aggregate functions because they aggregate over a group. And we saw the group by keyword. And what that keyword does is execute a grouping of all the rows that correspond to that particular field where there's an equal, so that they can be grouped in common. So TAs would get a group with TAs, profs would get a group with profs, anybody would be grouped with anybody, any column that we go by. So we have that group by, and if we have a group by, we can now generate, use an aggregate function, and we can generate, here is a query that basically is telling us for each job, what is the maximum salary for all the people that are in that specific job? And we can see that that's nice and logical, and that's great. Okay, so other questions about that? Still SQLite for homework 2. Yeah, I see that. You're still on SQLite for homework 2. Don't be, you're gonna, that's the last time you ever have to touch SQLite, though. You will be using SQL 3, SQL Server moving in. Okay, so we're clear on this. We talked about that Monday. Now, there's where I see we got into trouble, and part of the trouble was when the slides. So I'm going to redo some of that material and hopefully make that a little bit clearer in the first part of the lecture today. Okay, so here we have a query that is grouping by two fields. What does it mean to to use a group by and have a series of fields? What it means is it groups you in succession, first by the job, and within a job by name. Now, we didn't necessarily specify an order by here. So as long as they're grouped by job and name, they could be in reverse alphabetical order. That's fine. That's consistent with relational databases. But that's what it means to have multiple things that you're grouping by. Generically, in programming, we tend to call that a sort key because we're sorted. But in relational databases, we're not sorted unless we otherwise specify. By the way, a lot of these tables are sorted by their primary key. So they are sorted. They are in a sorted order. But that's another topic entirely, as we'll get to. Okay, so if you execute this group by job and name, you'll get this relation. Some people were confused about, well, how does that really work, or how to do this series of sort keys on the file, or grouping by keys. And I thought, you know, one of the problems is with this example. So let's look at a better example that I came up with yesterday. Now, what I did in this example was I added a user ID of 900. The name is Jack. Jack is a TA. Jack makes a ridiculous salary, good salary for a TA, but that's neither here nor there. So when you're doing a group by for job and name, what that means is within TA, you're also grouping by name. So you'll see the TA Jacks, they'll be a group. The TA that's just Allison, that'll be a group. So as the name and the job change, the grouping changes in that sequence. So executing this query gives us these results. It's a little different because Jack's an outlier here and makes a darn good salary for being a TA. Questions about that? Does that help at all? Those of you that had questions about that and didn't follow? Okay. So.
Oh yeah, we just got a question.
Sure. All right. Well, let me go on and see if you still have that question. I'm trying to anticipate what you guys are thinking about that. So if you accept with me that this is the result over here of that query, so then what was that query asking SQL? Basically, that SQL is asking to compute the maximum salary of TAs named Jack, or TAs, if there were multiple TAs named Allison, or professors named Dan. That's what that query would do. This is a computer. It does what you instruct it to do. That's what that query means. That's what that SQL statement means. Now, the question is that what you wanted to do? And I suspect that it wasn't. That query seems to me is an attempt to find the name of the person with the maximum salary in each type of job. That's probably what the author of this query was trying to do. Okay, let's see your questions. Yes, the first Jack was left out because that first Jack was not the maximum salary in that grouping, was not the Jack with the max salary. So the final result was definitely, whoops, not that. That's sort of the intermediate result. Was this? Yeah. We were asked SQL. This query asked SQL, group them by job and name, and give me the max salary of each job and name. I again added another column to the select, also so it'd be a little bit clearer. So yeah, the final result set would have a TA with one or more Jacks, TA with one or more Allisons, and we don't know from the results of the query. Question for you guys. If we wanted to add another indicator to the result set of how many people have the same name in the same job title, how would we do that? Anybody got an idea? Don't all raise your hands at once. select count is correct. A count of what? Does it matter what you want to count? See you? You could select a count of any of the fields in the group by, any of the fields. Okay? So that would tell me, oh, there's a bunch of jacks. But we know there's a bunch of jacks because we're looking at the raw data file, the original relation. Okay, everybody with me with there so far? Are there still questions on that one?
I think somebody had a question about does the order of the group by columns matter? Like, would name job be the same as job name?
Well, no, yes, this order does matter. This is the order in which you'll find the intermediate results. First in job order by job, or group by job, and then group by name. Not necessarily sorted order. So this ordering, this is in effect the logical view of the data that this query is going to operate on. And they're in order by job, and they're in order by job, and within a job, they're in order by name. Not necessarily alphabetical order, because it's a relation, that doesn't matter. In real SQL Server databases, they're often in some kind of sequence, and you would get that sequence, whatever it is. So the order does matter. You are specifying an order kind of like, actually identical to, having an order by statement in your output that affects only your output, that would order by job and name. It's identical, it has the same behavior.
But I think the question mainly was because Jack and TA, like both of them, like are the same fields. So the question was originally asking, because if we kind of group by job, then we get the TS together and then the name like Jack. But
right, well, that would be different. In other words,
yeah.
One here, what we're specifying here is we're grouping by job, and then within job by name. So if there were a Jack professor, it would never appear in the group associated with job. It would only appear in the profs. Okay, thank you. Does that clarify everything? What if we want to just count the number of jacks? You'll figure that out. You're going to get very good at SQL. You're not going to have to ask me these very simple questions. Let's not go there right now. Okay. Now, there's an important restriction when you use group by. And I'm going to dive into that a little bit because I found last year people got kind of confused. So I'm going to drill into that a little bit. Hang with me. We'll hopefully solve this. Just watching my time here. So when there is a group by clause, select can only reference aggregates and any columns that are specifically in the group by. That's it. If you do not do that, if you try to specify something else, like actually salary, which is not an aggregate. If you want job name, comma, salary, comma, max salary, SQL will throw an error. That's wrong. You are violating this constraint on the group by clause. It'll remind you. You got a nice parser. I'll show you an example of it later. Now, the question you might be asking is, why is this limitation necessary? And I think if you understand why the limitation is necessary, you won't question it anymore, and you'll absorb it. So I'm going to spend a minute deriving the limitation for you. Okay. Why is this limitation necessary? That I can't put salary in here if it's not in the group by. Okay. Well, you have to think about the logic. And here's the logic of how an aggregate is computed. Now, my data is grouped by job and then by name. And group by works on that ordering of the data. It's not a total order, not necessarily an alphabetical order, but it is in group order. Okay, so aggregates are computed for each group of, in this case, with this query, of TAs with the name of Jack. And for each, and looked at a row at a time within the group, And for each row in the relation, iterating a counter that I can use later for the count aggregate function. Or if I ask for sum, they accumulate, if I ask for mean, they also accumulate a sum, because the calculation for mean at the end of a group needs not only the sum of these two, but it needs the count. That's the calculation for a mean, the sum divided by the count. And it's fairly straightforward to calculate a minimum and maximum value for just comparing all of these values that match the grouping, and calculate the minimum and calculate the maximum. These are all values, these aggregate functions, that can be computed by going through a relation a row at a time. That's what we're limited to in these aggregate functions. Think of nested loop semantics if you want to think about it that way. It's because we're going through this relation one at a time. That raises a question. What is a logical, those are the standard ones supported by ANSI SQL 85. How could that be extended? That if you have to calculate something in sequence, what's the logical other statistic you could do as well? Any ideas on that? I don't think I have any ideas. You guys probably, maybe it was news to you that that's how you would compute a mean. If you could compute a mean, how would you compute a standard deviation? And you need not only the mean, but you also need the sum of squares. So you could accumulate a sum of squares in the same fashion at the end of the group, divide by the count. That pretty much gives you the variance. Square root of that gives you the standard deviation. So for instance, in SQL Server, in Oracle, most databases, even though it's not standard ANSI, they will let you SQL to have an aggregate function like standard deviation built in, because it just is another thing you can calculate as you go through these rows one at a time. And so what does that look like code-wise? So I'm not guaranteed, I didn't run this code. I wrote it. It should work reasonably well. I've written this code, I don't know how many times in my career, but here's some code that will do exactly that. Let's initialize some stuff. Let's initialize a counter field, a sum field, a max, and a min. Actually, that's the first mistake. The minimum has to be has to be initialized to the largest integer that can fit, or the largest number of its type. So that's a bug. That's my first bug I see. As I said, I didn't run this. And then I do some initialization where I get the first row, and I set up the sort key. And the sort key is whatever column I'm using in the group by, and then another key for the other column, and however I can group them as much as I want. And that sets up my first sort key. Now, I go for each row in the table. I find the sort key, I compute the sort key for that row. Whoops, I probably have some more stuff here. This is like a while loop. I wrote it as a for each, but I think of it as a while. It's while these sort keys are equal, I have a loop body that calculates these values. This is the counter, that's the row counter. This is the sum of all the rows in that loop that have the same sort key. And if column Y, which I'm using, what I want to max on, is greater than my current max, I move that into the max field so far that I've seen so far. If column Z is less than the minimum, then I move that as my current minimum. Line by line, that's all I do until the sort key changes. I pop out of the while loop and I'm in this else, and now I do my output. What is the current min? What is the current max? What is the row counter? How many rows did I look at? I can calculate the mean. What else can I put out from that row? The only thing, say there's 10 rows here, the only thing that I might know is the last value of these keys, of these other fields, but I do know the keys themselves, the values of the sort keys. And that's why those are the fields that are available in a select statement when you use group by, because this is how it's calculated. And I reinitialize it with a new set of sort keys. I have more rows I keep going through. And this is the way that I wrote it here. Make sure you output the last set of values. That's the code that is running aggregation, on SQL Server, on SQLite, when you ask for a aggregate function. Okay? I don't know what they teach you in programming class these days. Does this look familiar? Do you ever have to do this? I started when we had batch processing, and you had to do this all the time. You'd have two files, and they were sorted the same, and one was the checking account master file, and one was the current checks that were written. And you sorted them by their customer number, and you processed them kind of one at a time, and stayed on the master file until you ran out of, until the key changed on the customer detail. And then you did all your calculations for that customer. And then you went to the next master record and you read the customer file until you found it. You did that sort of thing. It was a little bit more complicated. That was maybe homework 3 when I first taught a course in programming, because I had written it so many times myself. You guys probably have never written this. Is that so? Does this look pretty unfamiliar to people? Yeah, I noticed my people in my data science. It does not look familiar. Well, that's why I'm showing it. I can see this program in my dreams. My first programming job, I think I wrote this variation of this about 100 times in the first year. It was an accounting application, big accounting for a big company. And most of the programs were just like this. You accumulated costs and hours for all the people in various departments and projects, and sorted all the data in different ways to produce something. Yeah, it was great. So I got pretty good at writing this program. So that was my experience. That's how you had to do it in those days. Okay. So that's what's going on with aggregation. And that's why there's this rule. That's why there's a rule that says when there's a group by clause, you can't put things in the group by clause that are not aggregates or the columns that are used in the groupings themselves, because the rest of the data is not kept in part of the loop processing. So it's not available for the query. All right, little known fact. All right, let me go through this and let's move on. Okay, are you ready? Now, hopefully that makes clear what we talked about on Monday. Now, let me confuse you all over again. So all that's being set up by a query, this query, which was, what I really want to do is find the person with the highest salary for each job type. That's what I was asked to find, and I want SQL to do that for me. And the answer that we came up with so far, not a particularly good answer, as we saw, because it's not going to do it. It's actually, and if we add, that's by job, so that's not so good. And in fact, because name here, well, actually, if you try that query, I think somewhere you get an error. So I pulled this, I think, out of Microsoft SQL Server, and you'll get, I want to execute the query. I think you have to actually try to run it. It's not something the syntax checker checks, but at runtime, it says payroll.name is invalid in the select list because it's not contained in either an aggregate function or the group by clause. So you'll get that kind of an error. SQL will try to execute it and say, hey, you can't pull that out. So that won't work at all. That is an approach that's not going to work. Let's put it that way. What we really want, what we're trying to do is answer this question, return the person with the highest salary for each job type. We try that one and we get a SQL error. So now we're scratching our heads. Where do we go from here? And there's the rule. Select, having, and order by can only use aggregate functions or any other attributes that are in the group by, because the other stuff goes away, as I showed you in the way it's processed. Okay. So how would we do this? If anybody has an idea who hasn't taken the class yet, but I'll give you a minute to think about it. What is the point of this again? Thank you, Lauren. The point is to find the person with the highest salary for each job type. That would seem like a reasonable query to ask of this data. How do we go about doing it? Because obviously the most obvious way of doing it doesn't work. Maybe use a join comes once kind of, what would you join? Multiple queries is one way. Ryan, you're punting the whole question. Do it in your spreadsheet. Wait a minute, go back up here. Can I make this window a little bit bigger? Let me see if I can. Oh yeah, okay. Vincent is on the right track. And the join idea is a good join. It's a good idea as well. Let me move it over here a little bit. Let me go to my controls. Okay. The main idea is we need, if we could create this table using a join or add to this table using a join, where each row would get the maximum for the grouping, then we could solve our query. Then we could execute our query. So we need a join to do that. In other words, we need a join that'll do something like, oops. Well, one way to do this is, it's like a self-join, is to do a self-join. By the way, I'm going to show you the hardest possible way to do this query. Next, when we get to the next topic, I'll show you a much easier and I think more intuitive way of doing the query. Again, it's relational algebra. There's a lot of ways to solve it. You may find that this is an intuitive way. I don't think so personally, but you're entitled to your opinion. I don't care. I'm not going to grade. We're not grading for style here. We only want you to get the right answer. And the right answer can be done in a couple of ways, but arguably so far, we haven't gotten the right answer. Okay, so one way to do this is a self-join. And what we would do is try to join a table, a relation that would show just the maxima for each job. For each job. Because that's all I care about. I don't care about the names, but I do want to pull the name out somehow. That's why it's called a witnessing problem. I want to pull out the name of the name in the database, the item in the database that is the witness to the maxima. So in other words, I want my query to be able to return 60,000. And if that happens to be Allison's salary, I want Allison's name. And I want my query to return $100,000 with Dan's name if Dan happens to be the highest paid professor in that title. Okay? SQLite. It works in SQLite. Well, SQLite is pretty stupid then. Quite frankly, it should not work. I mean, it lets you execute the query. Does it give you the wrong answer or the right answer? Who tried that? What? Does it give you the right answer? It gives the right answer. Amazing. It's not supposed to. I don't know how they got it to work in SQLite. So you could use SQLite. You're fine. You won't be using it again. Here's the query that'll work. This is a join. I got payroll once as P1, and I got payroll again as P2. I've got a where clause where I'm joining on job. That turns out to be significant. That's what, because I want I want to do this join based on the job. I have the maxima over the job. So what I need to do is compute the max salary from P2, and I am grouping by job, by the P1 salary, and by name. And this P1 name here means that I can pull it out as the witness to that max salary. So that's why that's added to the group by. And then now we're talking about an interesting use of the having. The condition is that the P1 salary that I want is the maximum calculated for P2. So this where, the self-join, this where, when I'm specifying the join on job, the combination of how I'm grouping it and then the having statement, that will work. That will pull out, there's a couple more here. That'll pull out Allison's name as having the max salary and Dan as having the max salary here. Can you explain why we group it that way? Because we group it that way. I don't know how to answer that except as a tautology. We group it that way because we're trying to find, why do we group it there? Because in order to have this witness, P1, be able to report the name from the unsummarized part of the table, we have to have it in the group by. Otherwise, it cannot be surfaced in the select. That's the significance of that. Otherwise, we run into the problem that apparently SQLite ignores, that you can't have something in a select statement that's not in a group by or isn't an aggregate computed for that group. Group by changes things, clearly, and I can't report it otherwise. Okay? Can I go back to the, yes, I will go back to show you some of how this thing works. So here's my raw data, and I'm trying logically to create this in the process. An intermediate step is the join. And here's a join where I joined on job, and I have the contents of both P1 and I have the payroll table twice. And everything is completed, is identical, duplicated. So these are the same column names because it's the same table. That's the output of the self-join by itself. If I wasn't grouping, if I wasn't having, if I wasn't doing anything else, if I just wanted to select star and payroll, if I just did that part of it without the group by and the having by and did a select star, I'd get them all. And I would get a P1 user ID and I get a P2 user ID. Because that's an equal join and a self join, two tables that I join together based on job. Okay. So the key is here that I am joining on the original grouping attributes. I really care about the max salary of the job, so that's how I have to do the join as well. Okay, with me there? Let me go on to the next one. So then you're grouping on any additional attributes that you need an aggregate for. And I need the aggregate for salary. So I include that in the group by. And I want to pull the name. So I want to, and all I'm doing is grouping here. I'm not selecting anything. I'm not doing, but I'm doing the logical grouping. And the logical grouping has now got all the TA data. And you notice there's a bunch of them. They're duplicated because they're coming from both tables. But the data is identical. You got Jack group with Jack, you got Jack group with Allison, you have Allison group with Allison, you have Allison group with Jack. It's a cross join in effect. You're getting all possible combinations of Jack with every TA. So if you do these self joins, by the way, they can get enormous, which is one of the limitations of relational databases. But that's what the intermediate join looks like, and that's how the grouping would work. And at that point, now I can execute the having, which is the order in which this stuff occurs. If you remember from last time, let me go back to that slide when we get through this, is then you're going to do the having, and the having, oops. Oh, okay. So here we're explaining that we've got we're grouping by the job and the salary and the P1 name. So that gives us grouping around all of Allison's connections and things of that sort. All of this is to get that get that name, get Allison into the final result. Okay. And so you're doing that group by. And then the having eliminates all rows that don't have Allison in it, where the P1 salary is not the maximum of the P2 salary. Since Allison has the P2 salary, any rows that don't involve Allison, they're gone. Okay. And that's kind of how this winds up. That's a way you would do it. I think that's probably the most difficult way I could imagine doing this. I'm going to show you a way of doing that I think is a lot clearer as we get into the next area, which has to do with how to write a subquery. I would do this writing a subquery. I'll go through the notes and make sure that there's an example that does it as a subquery, but you could do it this way. Keep in mind that it's a relational algebra, and there's a lot of ways to compute the same thing. Let me finish up. I have one more thing to show you, which is this FWGHOS is the order in which a SQL statement is executed, not the way it's printed. It doesn't really matter in what order you do the various clauses, but what is done first is the from. If there are multiple tables in the from, that's a join. Then it executes the where clause on the join tables. Then it does the grouping. Then it does the having clause. Then it does the, what is O? I draw a complete blank here. I think O is the order by, sorry. Oh, then it does the sorting. And then finally it does the relational algebra term for this is projection. It does the selection. It could be star, it could be all the columns that are left from the relation, or just specific ones. That's selection. So the order in which a SQL statement is actually not how you write it, but actually how it's executed is this. And it's a good idea to keep that in mind. From, where, then the group by, then the having, which does provide selection on the group by, any order by statement that you have, it's optional. And then finally pulling out just those columns in the final result. And the rule that we saw with aggregates is that we can't pull anything out of the intermediate result here that's not in the group by or actually an aggregate function itself. And I went through that programming exercise to kind of let you know that. So don't forget the rules regarding aggregate operations. Hopefully you'll be trying this out on a database where it will give you an error like the one I showed you if you do it wrong. It should tell you. It shouldn't just kind of say, oh, I think that's what you're trying to say. In the query as written, SQL should be interpreting that as, oh yeah, give me the maximum salary for all people in the same job with the same name. And that, unless you want that, you wouldn't write the query there. You might write the actual query the way this query was written. And I apologize for it being complicated, but kind of gets a little hairy once we get into these self-joins. When you start to practice with it, you're going to, and by the way, this is about as hard a query as you're going to have. Well, you might have some queries in homework that are harder. And the other point I'd like to do to have you rest easy is if you wrote this query as a subquery with a subquery nested in the query, it would be a lot easier, and you could do the join that way, and it would make a lot of sense to do it that way. And the kind of question that I answered out on the discussion board last night is the SQL optimizer understands how to make your query run the fastest. And queries that execute the equivalent and get you the same result set, SQL Server itself will figure out. So if you wrote it this way, or you write it with a subquery, the other alternative I'll show you, they're all likely to generate the same execution plans. It doesn't matter how you write it. SQL should be able to find an efficient way to execute what you wanted. What happens is sometimes you write your query and SQL will execute it, but you've asked the query in a way that it doesn't return what you really wanted. And this whole lecture has been about that. Somebody needs to get the name of the person with the highest salary group in the particular job type, but they didn't know how to write that query. And if you think about the query, it's no wonder that they didn't. It's fairly complicated. That's all the material I have for you today for lecture. I'll take questions now if you want in the class, or if you want to wait till that's another couple minutes and I open up the other meeting, we can do them one-on-one. Anybody got a question for me?
I do have a question. Is it possible to do this without join?
No, I don't think so.
Thank you.
If you come up with one, let me know, but I think not. I think you have to, the main idea, as it said earlier in the slide, is to find a way to get the maxima of the salary for each job type, each type of job, into the same, add that additional column into the relation. And then you have a fairly straightforward query to do. So, and sometimes you have to, pardon me, I sometimes talk about these slides like somebody else wrote them. Somebody else did. So for the most part, but I've gone in and modified them. So I'm not abrogating responsibility. I'll take responsibility for them, but sometimes I'm like, well, why did you write that? Why'd you put that on the slide? So logically, if you could create this relation out of the initial relation, and there's a number of ways to do that. And it's going to require a self-join, because this maxima, this column here, is basically a representation of this column, of the salary. So, yeah. And the reason why the simple query doesn't work, again, is this rule that select and having an order by can only use aggregate functions or other attributes in the group by itself. And my taking the time to go through the kind of processing loop for each, well, I always think of it as like a while loop. While the sort keys are equal, you accumulate intermediate results. When the key changes, one of the key fields change, then you have an opportunity to output the aggregates that you've been accumulating. And we call these accumulators, going back to the before we had electronic computers, they had mechanical adding machines. My dad had one in his store, and you could add up, somebody's order, I think, on the adding machine. And they work purely mechanically. You had a crank that you pulled and a series of notched kind of things from 0 to 9 for each digit. And what you could do addition that way, mechanically. Can't do multiplication. Multiplication sort of meant we were going to do this stuff electronically. And the very first computers were the equivalent of those kind of cash registers that would do those kind of calculations. Very simple oriented. And the terminology that we used, like register for a place to install this stuff and install your intermediate results, comes from those devices, mechanical devices. And they actually, the way an old-fashioned manual adding machine would work, you really only had one register, which is called the accumulator. So I've taken to calling them accumulators because that's really all you're doing. And these max, min, mean, standard deviation, count, they can all be accumulated in the body of that loop. That's kind of how we do it. Can you explain again what is the difference between from A join to B and from A to B, and there isn't really any difference? They are functionally the same as I wrote last night. So they are different ways of representing the same thing that the syntax supports. Join is implied when you have a from with multiple tables. So that's pretty much the same thing. When we're writing SQL, we tend to only use the join term when we have an outer join, and the order of the predicates matters. One has to be an outer, while the other one is the inner part of the outer, if you will. I don't know what you call it, the regular join. And we did discuss outer joins, and I think you have some of that on your homework, do you not? I haven't done the homework, so I don't remember.
Yeah, Mark, so
Yeah.
there is like a repeated question which is about why do we use p1.name and p2.salary? Like, why are those fields like different when we group by?
Well, they're not required, and I don't always use them. That's a good question. The person that wrote this likes to use them as a matter of style. I tend to only use them when I need to. You can't do, so this kind of query certainly doesn't require it, because every name is unambiguous, and the SQL syntax checker can find everything. They're all individual names in the payroll and from. Now, once you add another table, and that table has something that also has a column called name, you have to tell SQL Server which name you mean if you reference it in the select. It could be you have pets, people and pets, and you both have name fields in both tables. So you have to say pet.name, or you have to say people.name to differentiate in the SQL. People don't like typing out pet because it's a lot of letters. So they often, and you know, it's not a practice that I do unless I have to. In the way I write SQL, my style of writing SQL, I'd like to be as clear as possible. And I think it's much less much clearer to the next person that reads your code to write out payroll.name versus or pet.name and person.name or owner.name would probably be the name of the table. So sometimes the use of style is required. Also, the keyword as is swallowed by the syntax checker. So if you just do payroll space P, it's interpreted as if there were an as there. And this is the kind of thing people do in programming languages, you know, like lots of ways of writing an if then else without all the brackets and all that stuff just to save space. But they make it harder for someone else to read your code afterwards. If you're just programming for yourself, I guess you could pretty much do what you want. But if you're ever programming in an environment where someone else might pick up your code and work with it, that's the hardest job in the business, by the way, because understanding what somebody else is trying to do by reading their code is very difficult. It's very difficult. The first thing a developer comes along who has got that assignment does is, and you learn this the hard way, is they say, oh, you know, that code is horrible. It's got, you know, it's spaghetti code or whatever insult they apply to it. It needs to be rewritten. And you learn quickly as a dev manager that, no, we don't have time to do it. And the person that wrote that code might have been under the gun and might have been under deadline, but did it a pretty good job at it, and it does work. There's some reasoning there. You're looking and maintaining somebody else's code. You have to figure that out. Anyway, that's hard. That job is helped if you enhance the readability of your own code. Personally, I would always use, in this particular query, there's no ambiguity. But if I had multiple tables and there might be some ambiguity, I'd call them payroll job.
Yeah, so I think the student was mostly referring to like the witnessing problem, like where like we join.
So when we did the witnessing problem, there was clear ambiguity. So once you have that, you have, keep going. You have something like this. By doing this self-join, you have a single relation as the output of that with a copy of user ID in P1 and a copy of user ID in P2. Then you must disambiguate this because you just can't give me user ID. There's two of them. There's two names, there's two jobs, there's two salaries. There, the aliasing is required for SQL to figure out what it is you're asking them to do. So you have to use aliasing then.
And like a follow-up question, so would it matter if they do like p1.job, p1.salary, p1.name?
I'm sorry.
So yeah, like
Ask that again for me.
yeah. So another student was saying that like, does it matter if we do group by p1.job, p1.salary, p1.name?
I'm not sure what you're asking. I'm not sure what you're asking.
So instead of p2.job in like the fourth line, if we use p1.job,
That would work just as well.
okay.
Okay. That group, which job I reference in the group by probably doesn't matter. In the halving statement, you have to be very clear that you're going to do a halving that matches the salary of the one side of the self join